This video is going to explain how to solve problems using the sine rule. And as you possibly know already, this is the sine rule. It comes in two forms. Sine A over A is equal to sine B over B, which is equal to sine C over C. And you'll notice that you've got two types of letters. You've got the lowercase letters on the bottom here and the uppercase letters on the top. Capital letters are used for angles, and the lowercase letters, small letters, are used for sides of a triangle. Now, you can turn this whole thing upside down by a little bit of fairly trivial rearranging, so the other form that it comes in is this. Now, just before we leave these for the moment, the top form is the form you would use if you wanted to work out an angle. That's because the angles are on top of the equation, of the formula, and it's a lot easier to deal with something if you've got it on the top. The bottom form if you wanted to work out the side, and that's because the sides are on the top. Now let's have a look at a problem. So the first thing you need to be able to do is you need to be able to identify that a problem is a sine rule problem. And I think of the sine rule problems as Mexican problems. So some of you might have seen this before. Do you know what that is? No, it's a Mexican on a bike. There's his sombrero there, his big hat. And here's one for you to think about while we're solving the problem. What is this? Right, let's go back to the problem. Now, how do I know this is a sine rule problem? Well, basically I'm noticing that I've got an opposite side angle pair. There they are. An angle and the opposite side, I've got the side length. So if you've got a pair, an angle side pair, that's a pretty big hint that you have got a sine rule problem. And I like to think of it as Mexicans on a seesaw, for reasons which may become apparent later. Anyway, once you've spotted that, you can go right ahead and label up your triangle. So I'm going to label this up. Now, something that confuses people is that there's often labels already. This is triangle DEF, so there's already some letters on it. Now you must be very careful not to get confused with the letters that are already on your triangle. Now first of all, let's write the sine rule down. So I want to work out an angle here, so I'm going to need the angles on top. So sine A over A is equal to sine B over B, which is equal to sine C over C. So, labelling up my triangle, I'm going to call this one angle A, which means this one is going to be side little a. This angle here, I'm going to call angle B, which means this is side little b. It really doesn't matter what I call them, as long as the opposite pairs have got the same letter, although obviously the angle is large and the side is small. Now, if you look at the sine rule, I'm going to use this piece of it here, because I'm using angles A and B. So I'm just going to substitute now. Sine A, big A is 84, and that's divided by 92, and that equals sine B, well B is x, we don't know how big it is, that's what we're working out, and it's over 63. Now, I want to get the x on its own, so first of all I'm going to get rid of the 63 here. I'm going to multiply both sides of this equation by 63, because that's on the bottom, it's a divide. So I've got sine 84 over 92 times 63 equals sine x. And I'm going to type that into my calculator, and when I type that in, I'm just going to show you what it should look like. It should look like this. Now, notice that what's on the screen here looks exactly like what I wrote down, yeah? And that's really important because, let's go back to it, that's the point of getting these calculators. I used the fraction button to get this line. The fraction button has two squares with a line in between them, and then this big button here I used to move the cursor along so that I could have the 63 and it wouldn't be on top of the fraction button. And I've got my answer there, 0.681, so let's write that down. 0.681. Now, We're almost there. Notice that what I've worked out here doesn't sound very reasonable for an angle. I mean, if this is 84 degrees, 0.681 just doesn't sound very good. And that's because it's not the angle. What we've just worked out is what sine of the angle is. And this is something that always happens when you're solving angle problems with trigonometry. I need to get the sine off it, and to do that I do the inverse sine 0.681, and I use my calculator to do that. First of all, I make sure it's in degrees mode, and sine of 0.681, and that gives me an angle of 42.921, and the question asks for one decimal place, so that's going to be 42.9 to 1 decimal place, and that's 42.9 degrees. And that is how you solve a sine rule problem. Let's have a look at another one. Okay, so this is off a fairly recent exam paper, and when you look at this, the first things you should notice is it's not accurately drawn. That's telling you not to bother measuring anything, so don't get out your ruler. And then there's these two little lines. That's telling us that it is an isosceles triangle, which means that this must be 8 centimeters. Now, without going into much more detail on this, I'm thinking already isosceles triangle, that means that I must be able to work these two angles out here. So let's do that. So that's 140. So I'm 180, take away 140, leaves me with 40. There's two angles, so it's 40 divided by 2 because they're the same size, and that's 20. So these are both 20 degrees. Brilliant. Okay, calculate the length of PR. Well, a nice way of doing this, is not the only way, is to use a sine rule. And how do I need to use a sine rule? Well, I've spotted that I have got my Mexicans on a seesaw. There we are, opposite side angle pair. It's all about spotting the patterns, which means that I can use the sine rule. And this time I'm after a side. There it is. So let's write the sine rule out, and I want the sides on top. So A over sine A is equal to B over sine B, which is equal to C over sine C. So I'm going to label my triangle up now. So this is my pair that I've started with, so I'm going to call this one angle A, which means this is little a, and I'm going to call this one B, which means this is little b. So I'm going to use, once again, I'm going to use this bit of the sine rule here. And I can just go ahead and substitute now. So little a is 8, and that's divided by sine of 20, and it equals little b, which we don't know yet, divided by the sine of 140. And as before, I'm going to rearrange it to make b the subject, so I'm going to multiply both sides of this by sine 140. And I would write it over here, except I don't have room. So I've got 8 over sine 20 times by sine of 140, and that'll give me b. And I put that into my calculator now. I'm going to type it in using the fraction button first. So fraction button, 8 on the top, sine of 20 on the bottom, and then I use the cursor key to move it along, times sine of 140. And my calculator is saying that b equals 15.035. Now, that sounds reasonable, doesn't it? I mean, 8 centimeters, 15 centimeters. They want the answer to 3 significant figures, however. So just to finish that off, 1, 2, 3. So b is equal to 15.0 centimeters, and that's 3 significant figures. And there we are, another sine rule problem. Mexicans on a bike. Oh, I didn't tell you what that other problem was, did I? Let's go back. This thing here, and you'll work out what it is. It's a Mexican visiting the pyramids. Okay, here's another one for you while we're doing this problem. Can you figure out what this is? You'll never guess. There we go. Good luck with that one. Right, now I've put this one in because I thought I'd just put in a problem that actually isn't a sine rule problem, just so you can see why not. So I'm looking at this and I've got three sides here, brilliant. There's no right angles, or at least I'm not sure there's any right angles. I could test to see if there's a right angle to see if this obeys Pythagoras, but I'm pretty confident it doesn't. And there's no angle side pairs, there's no Mexicans on bikes here, because I've got an angle I don't know, so that's not a pair because I don't know the angle, and I've got, well, I don't know the angle here either, and I've got another one, and I don't know the angle here, so there's no pairs whatsoever, so this is not a sine rule problem. This is in fact a cosine rule problem, and if you want to know how to do that, you'll have to watch my cosine rule video when I finally get around to making it. There we go. So let's carry on to another sine rule problem. Okay, so often when you look at a problem, you don't know if it's a sine rule or a cosine rule problem. So let's just take how you'd approach something like this. Horrible looking picture here for some of you. Notice the the writing here is telling us this is a building here. Let's put a window in it. There we go. And it's standing on horizontal ground. It's all telling us what the picture tells us. So let's go back to the picture. The first thing I notice is that I could work this angle out here. So 180 take away 78 is 102. 102 degrees. And then I'm looking at a triangle here. Well, I could work this angle out here, couldn't I? So 102 and 65, 167. So this must be 13 degrees. And of course I could work this one out too. 90 and 78 make 168, which means that must be, give you a moment to work that one out, it's 12, isn't it? So, and that's not taking anything. Now, I've got some more angles, so now I'm going to start looking for my clues. Now, obviously I've told you it's a sine rule problem, but you wouldn't know this necessarily. The thing to notice here, though, is look, you have actually got some Mexicans on a seesaw. So we can use the sine rule. It's not immediately clear what we'd use it for, because certainly we can't use, this is not a side of the triangle, but it's quite common in these questions to give you a couple of triangles, and you have to work out something in one before you can get to another. So we could either work out this side or this side. So we're going to use the sine rule, and we're going to work out a side. So let's go and do that. So sine, so A over sine A is equal to B over sine B, which is C over sine C. So let's label up our triangle. I'm going to call this one angle A, which means that's little a, and I'm going to work out this side here, which means this angle is angle B because they're opposite. So let's try them out. So I'm going to use once again the first bit of the sine rule. So little a is 50, so 50 over sine 13 is equal to B, which I don't know, divided by sine of 102. And then I'm going to rearrange it so that B is equal to 50 divided by sine 13 times sine 102. And when I type that into my calculator, which is what I'm about to do now, so fraction button, 50 over sine of 13, and then multiply it by the sine of 102. Mr. Calculator says 217. 0.41 for what it's worth. Okay, so we look at that and we think, crumbs, that's a big number. But actually, if you look at it, it probably is going to be a big number. I mean, after all, this is 50. This isn't to scale, but if that's 50, then you could quite easily have 100 or 150 here. So 200 is not an unreasonable number, really, here. At least it doesn't seem so. 217 meters. So that's what B is. So I'm going to write that here. So that's 217.41 meters. Now, very easy to get confused. My diagram's got a bit confused here. So I'm looking at it and I'm thinking, how am I going to work out the height of the building there? And I notice there's a big triangle here, and I've just worked out one side of it. So I'm going to draw that big triangle over here. so it's really obvious to see what I've spotted. So this angle here is 65 degrees. This side is 217.14. There's a right angle here, and that's the side I want. So you look at that and you think, great, it's right angle triangle, it's either Pythag or Sokotoa. Clearly it's Sokotoa. So let's do this. So hypotenuse, opposite, adjacent, Sokotoa. Okay, how do we choose which one we want? Well, we want to work out h, which means it's got to be one of these two. It can't be this one because there's no h in it, so we can't work out h if h isn't in it. Which leaves us the choice of these two. Well, my apologies. We're not working out h, are we? We are working out o. And you can see now a demonstration of why it's very dodgy when you've got a letter that is the same as one of your labels in your formula. So we don't want to work out h, we want to work out o, which rules out ka. So it's between so and toa. Now, if we want to work out o, that means we don't know it, which means that the other thing we have to know, and that's h. So, pardon me. Okay, so it's this one. Let me just go over that again, because I think that might have been a little bit unclear. We want o, although I thought it was h, and we know h. And that is how I know it's a SO question. So let's get on and solve that SO question. SO, and I'm using the nasty little triangle here, looks like that. And we want to work out the opposite, so we cover up the opposite, consider that covered up, and we can tell that O is equal to S, which is sine x, times h. So we've got sine of 65 times 217.14. Out comes the calculator. Sine of 65 times 217.4, and we've got a number of 197.03, and they want it to 3 significant figures, so that is 197 meters, and that's 3 SF. And there we are. That's how you use the sine rule. I hope you found it useful. If you did, then click on the like, because so far nobody likes my videos.